Welcome back, class. Today we're going to get started on section 10.1, right? 10.1. And this section here is going to be correlation. 10.1 and 10.2 are going to be the last section in this unit, right? And this means everything from 1.1 all the way to 10.2 is going to be on your test one, right? So be on the lookout for the test one review. And let's get started, right? Oh, correct. This section here, right? We said we're going to be talking more about correlation, right? In the previous sections, we vaguely spoke, talked about correlation. I did say we were going to talk more about it, and this is going to be the section that we talk about it, right? So the correlation, we 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 deal with correlation whenever we plot the x values on an axis and the y values on an axis, right? So we're playing points in, right? And based on the graph, right, we can tell if there's a positive correlation, a negative correlation, or no correlation, right? And for example, the figure one here, the points lie to a straight line, which has a positive gradient. In other words, it has a positive slope. It's rising, right? If you were in a vehicle, right? If you were in a little car driving from left to right, right, you're going up, right? So that's a positive, that's increasing, right? And again, if you're driving from left to right and you're going down, right, you're going downhill, right? That's a negative correlation, right? And your R values, right? The correlation, instead of writing correlation the entire time, we're going to be using the letter R, right? For samples, right? It's going to be the letter R, right? And our R values are only between -1 and 1. They can be -1 and they can be 1, but nothing more than that and nothing less than that. It can be 0 and that's fine, right? The closer R is to +1, the stronger the positive correlation is, right? And the closer it is to -1, the stronger the correlation is, right? And we can see that by these charts here, right? You can see those by these charts. So okay, let's go ahead and move forward. Right, we did say that there's different symbols for correlation, right? And for this class, whenever we're talking about a sample correlation coefficient, we're going to be using the letter R, right? Whenever we're dealing with a population correlation coefficient, we're going to be looking at rho, right? Greek letter rho, which looks like a P, right? It looks something like this. It looks like a P. For this section, right, we're going to be focused on sample correlations. So we're going to be focused on this one. But remember, for population, it's going to be rho. Right, looking forward into the next sections, right? Let's just, right, this is a foreshadowing, right? That the t-test is going to be used to test the significance of the correlation coefficient, right? And more on this, we will have more on this later. And now we're going to go ahead and touch up on some real life examples of relationships, right? Relationships between X and Y, right? So for example one, choose a pair of quantities that is more likely to be related, right? Right, so I'm looking for a strong relationship, a strong correlation, right? So I have here option A would be the number of hours a student spends studying and the number of letters in the student's name. That's pretty much saying, does my grade depend on, the letters in my name? Seems kind of odd, right? Or option B, the number of hours a student spends studying and the score on the student's exam. That's more like it. There's a stronger correlation there, right? Because this means, right, the more you study, the more x increases as x moves to the right, as x becomes positive, my test grades will also be increasing, right? So in other words, as x increases, my y is also going to increase. That's a strong relationship, right? That's a strong relationship. Example 2, choose the pair of quantities that is more likely to be related. A person's shoe size and weight, Hmm. Or a person's shoe size and height. What do we think? That's correct. A person's shoe size and height. And right, probably where our minds are going to go are basketball players. Right? Basketball players are pretty hot, I mean, are pretty tall, right? Um, and there's a strong correlation between shoe sizes as well. Let's go to another example. Example 3, right? Choose the pair of quantities that is more likely to be related. The number of hours a worker puts in and the distance that worker lives from work. Well, no, right? Because some people live pretty far, but they're usually putting overtime. So maybe, right, maybe. Assume the worker is not paid for time spent driving. Ah, okay. Or the number of hours a worker puts in and the amount of that worker's pay, of the worker's take home pay. Oh, definitely this one, right? Because this pretty much states that if these are the hours you work and this is your pay, it makes sense that the more you work, the higher your pay is, right? So yes, it'll be option B. And let's go ahead and look at example 4. Choose the right. Let's choose the more one that's more related than the other. The number of hours a student spends studying and the number of hours that the student spends watching TV. Ah, right. Or the number of I see a correlation there, right? The the less that person is studying, the more TV is being watched, all right? Or the number of hours a student spends studying and the number of times a student has been to Disney World. Huh. Well, that's pretty odd, right? Because you can study all you want, right? And that's not going to guarantee that you're going to go to Six Flags or to Disney World or Knott's Berry Farm, right? That's not going to guarantee anything. So I'd say the top one, right? Specifically, right? Studying should go here. Study and watching TV. Watching TV. This means that the more you're watching TV, right? The more you're watching TV over time, the less studying you're going to be doing, all right? So if you're studying if your studying is pretty low, all right, that's a low Y. That's going to indicate that you're watching a lot of TV, right? So that would be a negative correlation, right? Right. And we said that, so for both of these cases, I need you to understand that as X increases, right, Y can either increase or Y can either decrease, right? So let's look at option 1. As X is going to the left, my Y is increasing, right? And we saw that on the previous slide, right? So that's going to be a positive relationship. And again, as X is increasing, right, my Y is decreasing, right? My Y is decreasing. So that would be a negative relationship. Right? And here, I want us to ask ourselves, right? Is there a positive correlation, a negative correlation, or is there no correlation, right? Or is it uncorrelated, right? So the first example here is going to be the number of class meetings missed by college students and their average scores in the course, right? That would be the number of class meetings missed by college students and their average scores in the courses are likely to be negatively correlated, right? Because that means right? That means that the more you're missing class, right? The more you miss class, what can we assume? That your grades are going to drop, right? Okay, what about this one? What about the age of a person and the probability that he or she wears glasses or contact lenses? Right? It wouldn't be a negative correlation like the one that we saw. It'll be a positive correlation, right? This means that the older we get, the probability of us having to wear glasses is going to increase, all right? So the age of a person and the probability that he or she wears glasses or contact lenses are likely to be positively correlated, because as the person gets older, the likelihood the person wears glasses or contact lenses wears contact lenses or glasses increases, right? Increases. Right? And again, we're going to be borrowing some stuff from college algebra from our previous courses, right? And specifically, it's going to be the graphing part, right? Specifically, it's going to be the graphing part. And let's focus on this first example, right? Right, you're going to have a column for your x values, a column for your y values. And I'm going to want you to put these as points, right? As x, y points. So that's going to be 1, 1, right? That's a point. What would be my other point? Very nice, 2, 3. What would be my other point? Correct, that'll be 3, 4, 4, 5, 6, 8. Now I'm going to graph those, right? I'm going to graph those and give my educated guess on the correlation, right? Based on my on what we see, right? So that's going to be my x, that's going to be my y. Let's just say that's 10, that's 5, that's also, let's say that's 5. What do y there? X 10, meaning 3 is here, meaning 8 is here, meaning 3 is here, meaning 8 is here. So the first point, right? 6, 7, 9. 1, 2, 4, 6, 7, 9. Right. So my first point is going to be 1, 1. It's going to be right there. My second point is going to be 2, 3. Right there. My second point is going to be 3, 4. So right there. My next point is going to be 4, 5. So right there. And the next point is going to be 6, 8. Right. What can you tell me about this line, right? What can you tell me about that correlation? That's a positive correlation, right? That'll be, you can imagine a line crossing like that. That'll be a strong correlation, a positive correlation. Right. Let's go ahead and do this other problem. I want this as an x, y's, right? And let's keep a track on our x and y columns, right? Your x column isn't always going to be, might not always be the first one given, right? So this here is 1, 1. This is 2, 2. This is 5, 1. This is 8, 5. And this is 1, 6. And one thing I also wanted to mention was, if you have a strong correlation with x and y, right? If your correlation is going this way, if you were to flip your axes, right? Let's just say y and x, there's still going to be a positive correlation. So the correlation always holds regardless of what you do to your axes, right? So if it's positive correlated like this, then it's going to be positively correlated like this. So remember, that's going to be very important. All right, so let's go ahead and plot this. All right, let's just say that's 10, that's 5, 1, 2, 3, 4, 6, 7, 8, 9. Let's say that's 5, let's say that's 10, 1, 2, 3, 4, 6, 7, 8, 9, right? This is my x-axis, this is my y-axis. Let's plot these points. 1, 1, 2, 2, 5, 1, 1, 6, and 8, 5. Is that a strong correlation, a positive correlation, a negative correlation, or no correlation? No correlation, right? There's definitely no correlation here, because I can't draw a line, right? I cannot see a line. Everything's very, very fuzzy. So it's clear to say for both of these, I would say my R is going to be closer to 1 on this example, and my R is going to be pretty close to 0 on the second example. All right. Which will take me to here. To distinguish correlations given the graph and the R. I'm giving two graphs, right? I'm giving graph 1, right? Looks pretty curvy, right? It looks something like, it does something like that. and I'm giving another graph, right? Graph 2 that looks more lined up, right? More lined up. And I'm asked, one of the two scatter plots below has a correlation, the correlation coefficient of 0.x6, and the other correlation is 0.30. Find those, right? Which one belongs to which one? And we need to remember that the one that has the more straighter points is going to be closer to 1, all right? So I would say between 0.86 and 0.30, this strong one has to be 0.86, leaving the one that's not as straight closer to 0, all right? Closer to 0. And last but not least, finding the correlation, right? So you're going to be giving two axes, right? And one, I'm sorry, two columns, right? The table below shows data for a study relating a man's age to the average number of miles he can cover on foot in 1 hour, right? So at age 18, they can cover 5.7 miles. At age 25, 5.6, and so forth. And I'm asked here, use a graphing calculator to find the correlation coefficient for this data, round to 3 decimal places, right? If you have already a graphing calculator, you can follow the explanation on this problem if it pops up in your 10.1 homework assignment, right? I've already put the instructions there so you can use a graphing calculator. If you don't, that is fine, right? If you don't have a graphing calculator, that is fine. You're not going to be asked in this class to find the correlation, right? Because you can solve this by hand, but it takes a pretty long time, right? It'll probably end up taking you maybe half an hour to find it, right? But I want us to understand it, and let's focus on trying to solve it, right? So I'm going to use a graphing calculator known as Excel, right? Known as Excel. So this problem, you're going to have to input manually into Excel if you do not have a graphing calculator, and that's fine, right? I went ahead and input these by hand, no problem, right? And then what you're going to have to do with Excel, right? It's not going to have the correlation option right away, right? You're going to go to File on this top left, and you're going to go down to Options, right? You're going to go down to Options, right? When the Excel options pops up, you're going to go down to add-ins, and then you're going to click on analysis toolpath, right? It should be like this one, but it more than likely is going to be down here where it says inactive application add-ins, right? You're going to click on analysis toolpath, and you're going to click go, right? You're going to click go, and you're going to see this table pop up, and you're going to want to click on analysis toolpath. You want that checked. You're going to click OK. It's going to do its magic. And then you're going to want to go up here to data. All right, you're going to want to go to data. And then I'm going to want you to go over here to analysis and click on data analysis. Right, when data analysis, right, it's going to give you a list of things you can find, right? I see this here, right? T-test paired to samples for means, right? Regression, sampling, moving average, histogram, Fourier analysis, right? These are things we're going to be familiar with. I'm going to covariance as well. Covariance, right? That's going to come up later, but I'm going to click on correlation. I'm going to click on OK. All right. You're going to click on this input. You're going to click on this upward facing arrow, and you're going to highlight the values that you want. All right. I'm going to highlight here. Then I'm going to click back on this arrow. So I've highlighted my values. And then for my output range, I'm going to click on that arrow, and I'm going to click somewhere here, right? Anywhere else, in any cell, right? Let's say up here instead, C1. All right, I'm going to click the arrow down, and then you're going to click OK. Boom. This value right here is the one you're looking for. And let's mark it green. That right there, that is your correlation, right? That is your correlation value. So in other words, R is equal to negative 0.96. So what can you tell me about that, right? Is this a good model? I would say, yeah, that's a really, really good model, because 0.96 That's pretty close to -1, right? So I would say yes, since the correlation coefficient is pretty much very close to -1. This linear equation would be a good choice for modeling my data, right? This should give me a strong correlation, right? So this covers section 10.1. Remember to also cover section 10.2. If you have any questions, don't hesitate to send me out an email or to contact me. Remember, go ahead and take advantage of the tutoring hours, right? Online tutoring is open Monday through Sunday online, all right? Monday through Sunday online. So if you don't have any other questions, thank you for your time and I hope you enjoy the rest of your day. Thank you.